Hey, morning, welcome. Today we're going to be talking about using SMOLAgents framework to build an AI agent, which will automatically scan web application codes for vulnerabilities, and then based on the vulnerabilities found, it will develop proof of concept exploits so that we can test for those vulnerabilities. This is a subsection of the AI Agent Smith training that I gave previously, and if you want to know more about the next time I'm going to do it, reach out in the comments below. All right, SMOLAgents. This is a SMOL means small, right? So small framework to help you build AI agents. It's built and maintained by Hugging Face. Hugging Face is a SaaS platform which has a bunch of utilities for running and building and modifying LLM models. So yeah, if you haven't played around with Hugging Face, definitely encourage you to check that out. And just the fact that this is from Hugging Face means any of the models that are inside its ecosystem you can use with it. So there's already thousands of models in there, as well as the framework supports LiteLLM. LiteLLM is a third-party open source project which acts as a facade or translation layer. So when you're calling APIs using the OpenAI format, even if the LLM provider has a different API format, this library will go ahead and translate those back and forth. So if you want to use something outside the Hugging Face ecosystem, LiteLLM will do that translation for you and make it possible for you to use other providers like Gemini and Anthropic and any of the other major providers. LiteLLM in and of itself supports over 100 LLM providers, so whatever you're looking for is probably in there already supported. One of the main advantages of the SMOL framework is this concept of code agents. So in your traditional function calling / tool calling agent design, typically you will tell the LLM about the tools that are available, and when the LLM wants to call a tool, it's going to return back to you a JSON blob. Now, you're going to have to take that JSON object and you're going to have to parse that inside your Python code, and then you're going to have to send the data that the LLM wants to the functions inside your Python code. After parsing the JSON file, then you're going to have to get the results from that function and send that data back to the LLM, and then the LLM can make its next step decision. So SMOLAgents is much faster, and the key reason is because they've programmed this so that instead of requesting JSON to come back from the LLM provider, they're actually requesting native Python code to come back from the LLM provider. And then they're just taking that native Python code and they are evaling it inside of your AI agent ecosystem. Now, obviously that comes with certain security risks, and they've implemented a lot of guardrails inside the framework to try to reduce those risks. From my standpoint, I do a lot of my work inside containerized environments, so it's easy to reset it back to a known good state. Now, based on my limited testing, I haven't actually ran into a case where the SMOLAgents framework got back like a malicious Python code or something like that, or a destructive one. So I haven't had any issues, but it is theoretically possible. So you may not want to run this from like actual hardware, right? You probably want to run it from a virtualized environment or a containerized environment. There are certain guardrails that are built into the framework. So namely, you have to explicitly allow what other modules that the Python code can import. So, you probably don't want to give it access to like the OS module, because then it could run commands, it could read and write files, which could, mess up your hardware systems. But yeah, I haven't had any issues, and it's really fast and really slick. So that's why I'm showing it to you today. Now, when the user task comes in, the framework's going to have a memory system that's going to automatically remember past queries, which is pretty standard for a lot of these AI frameworks. We're also going to be using a pretty standard methodology here. We're going to be using the React methodology, which is like reason and an act methodology. So, if you've done anything with AI agents, you've probably heard of that before. And then essentially, we're just going to get the code back from the LLM that it wants us to eval and run it, and then return the results back to the LLM again, until finally the agent is happy with the answer and then returns that back to the user. One thing to note is that by using this code agents approach, they say that you need 30% less steps to get the LLM to solve problems, and which means 30% LLM calls, which means reduced costs. And I would generally agree with that metric. I feel like the agents I built in this framework are a lot faster at getting work done than in the other frameworks. All right, so this is kind of an example of how it works. We're running this app 001. It's gonna give the prompt to the LLM. Could you give me the 118th number in the Fibonacci sequence? We're calling the Hugging Face APIs here, and we're using the Qwen 2.5 coder 32 billion parameter instruct model. So, it just returns back the native Python code to calculate a Fibonacci number, and we just run that to get the answer. So you can see, right, obviously less complex than the JSON parsing type methodology. There are base tools installed in the framework, namely DuckDuckGo for search and the Python code interpreter for the code agent. There's also a transcriber which uses the speech-to-text whisper technology. I haven't tested that, but both DuckDuckGo and the Python code interpreter tools seem to work great on all my test cases. So Hugging Faces is really an ecosystem, kind of the GitHub of the ML/AI world. I highly encourage you to check it out. They have a lot of open source models there, from image generation to text generation to way more. Also, when you log into Hugging Face, you can see the hub view, and the hub view is where all these models are located, and there's a lot in there, so it's kind of a good late night activity, just browse around. There's also a cool section called Spaces, which are basically mini web apps that other people have made to test bleeding edge ideas associated with AI concepts or ML concepts. So, for example, the one I was looking at last night could generate a 3D world, kind of like The Sims, right? If you ever played SimCity. Okay, great. All right, so in SMOLAgents, in a previous video, I talked about building a small agent to solve a CTF, so check out that video if you want more information there. In this video, we're going to be talking about building a small agent that's going to use the OpenGrep tool. This tool is going to go through and it has a set of rules, and it's going to use those rules to try to find vulnerabilities within the web application. And then as the next step, it's going to go ahead and try to develop the proof of concept exploit in Python to actually exploit that vulnerability. This is a good tool. You should run it against all your web apps. All right, let's flip over the codes and let's see how this is working. So in this first example here, we're gonna go ahead and pass in it the code subdirectory. Now the code subdirectory has this Python app here. This is a Python app associated with like a malware's listening post. And it has some pretty trivial bugs in it. So we want to find bugs in that listening post code. Now we're gonna go ahead and scan it using OpenGrep. We're gonna save the results to this JSON file. And yeah, that's pretty much all that this first script does. So let's check this out. Python app 001. And we'll go ahead and run that. So really not calling any LLMs yet, but this is going to produce this OpenGrep scan JSON file with the vulnerabilities it found. So let's go ahead and check that out. So you can see it found a few vulnerabilities, some SQL injection vulnerabilities and others. So we just want to make sure that our tools are working as expected. And here, OpenGrep is working as expected. So we'll move on to the next one. All right, in example number 2, we are going to read this JSON file that has the vulnerabilities, and then we're going to take that information and we're going to insert it into a prompt, and then we're going to send that off to an LLM via this generate POC exploit function, and then we're going to save the exploit script to disk. Let me show you what that prompt looks like real quick. This is my prompt. It has a couple variables, right? So one is information about the vulnerability in dictionary format. One is information about the vulnerability in markdown format. And then the actual content of the file that's exploitable. We could feed it a little bit more context, but this should be sufficient. And then it's going to return us the exploit script in between these tags called exploit script. So we'll just parse for that when we get the reply from the LLM and then save that result to the Python file. Okay, so we're going to do this here. We're going to go ahead and do Python app 002, generate the POC. There's only one JSON file, so we just select one, but there's 7 vulnerabilities in there. Just for simplicity's sake, we're just going to go with the easiest vulnerability here, number 6, which is kind of like a command injection vulnerability in the web app. Now, it's going to take information about that vulnerability, it's going to insert it into this template, it's going to send that off to the OpenAI APIs, and then it's going to get back the proof of concept exploit script and then save that to disk. So, it will take a second to communicate with OpenAI. They seem to be going a little bit sluggish today than they were last week. And I'm not sure on that why, but, they did just release some new features, so maybe they're being hammered. While that's generating, I'm going to flip over to the third example. In the third example, we're going to combine together example 1 and example 2. So we're going to scan the code, we're going to generate the JSON file that has the vulnerabilities, then we're going to read those vulnerabilities and send them off to the LLM, and it's going to generate the Python code. So just really combining example 1 and example 2. All right, so example 2 finished, and here we see I generated the Python code. So if we go to the Python code, we can see it's using the HTTP request library. That's going to send a payload with the command, which the web app is going to run. And here's an example. They're running the ID command. So this looks good. This looks like what it should look like to exploit the server. Okay, so now let's try to combine script 1 and script 2 together. And we'll test that out in script 3. This will take a few minutes to run. So there we go. I did the code scanning, found the vulnerabilities. We'll do vulnerability number 6 again, as it's the easiest, and sending that off to the LLM with info about it in Markdown format. And now the LLM's generating the proof of concept Python code and saving it to disk. So pretty smooth. While that's running, those previous scripts were not an AI agent. They were more just testing to make sure that the functions, and which are going to become tools in the AI agent, work as intended. So, we have a function that runs OpenGrep to find the vulnerabilities. We have another function that talks to OpenAI, sends it the data, and then gets back the proof of concept exploit script. So now we're going to take those functions and we're going to turn them into tools, and we're going to use the small framework, and then we're going to just let the agent decide what it wants to do to create the exploits. And we're going to try to have it create exploits automatically for any vulnerability it finds. So, we saw before it found 7 vulnerabilities, so theoretically it should create 7 exploit scripts. Just going to go ahead and clean up the environment real quick so it's less confusing for us. And then we're going to go ahead and run the AI agent here, AI agent Smith. Okay, so we can see here we've loaded up the small framework. We've given it the prompt here. We're using the Gemini 2 Flash model, but it decided to run the OpenGrep tool, and it found those vulnerabilities and saved them to the JSON file. And now, based on that, it's going through each of the vulnerabilities and sending those off to OpenAI to generate a proof of concept Python script. So we'll just kind of dive through this a little bit closer. So we can see here that when we declare the code agent, we're going to declare some custom tools. So we're going to declare the scan code for vulnerability tool, the select the vulnerability tool, the generate the proof of concept tool, the save exploit script tool, the load vulnerability data tool, and the analyze and generate exploits tool. We're also going to authorize it to use the following imports: base64, bin, ASCII, codex, request, libURL, time, sys, args, JSON, OS, datetime, read, pbprint. And we're going to limit the number of steps it can do to 10. And we're also going to add in the base tools, which give it internet search and the code execution features. So here's the prompt that we're kind of using here to talk about to scan the code. And then we tell it, hey, use this to analyze it and generate the exploits. And then in here, we kind of list it through the steps that we want it to take in the prompt. We also give it some backup options in case it gets stuck. And yeah, that's pretty much the prompt that we're using for this agent. We can dive into some of those functions a little bit more while this is still running. So analyze and generate exploits. Here we're passing it in the code directory, and we're also passing it in the generate proof of concept exploit markdown file. We saw that before, but that needs those 3 parameters. So here we're calling the scan code for vulnerabilities function, which is just running OpenGrep, and we're formatting some of the data and generating the POC, saving the exploit script, all that goodness. We've also got the load vulnerability data function, which is going to read the JSON file. We've got the save exploit script that's going to save the Python exploit to disk. We've got the generate proof of concept one. So here we also have kind of a prompt inserted here. And the main point of this prompt is I just wanted to kind of make sure that the model wasn't going to complain that we were doing something evil. So I just told them, hey, we're a security expert, right? So it's less likely to complain to us. And up here, selecting the right vulnerability for which we're going to generate the exploit. Scan code for vulnerabilities, that's the running the OpenGrep, and some optional parameters you can run the script with. The app.ini file, we're just really defining model names and keys in it. So pretty straightforward. And let's see here. One thing that I just want to highlight, if you're trying to get this running, while it's still generating exploits for us, it's on 6 of 7 exploits, is if you're running this on Mac, I use this dev containers extension in VS Code /cursor to load up this in a containerized environment. I could not find an open grep build for a ARM Ubuntu instance. So what I did is I created this Docker file, which just says, hey, use the AMD64 version of Ubuntu 22.04. And then in the dev containers file, I just referenced the Docker file, and that's how I built it. Now, if you've already started up dev containers, you can use this dev containers rebuild container after you modify these files to rebuild it in this architecture type. And then you should be able to run this open grep any Linux x86 binary. And I've just copied that over to be open grep. If you're on a different architecture, you may need to copy the right binary over. I also have this setup.sh file, which will set up your Ubuntu 22.04 environment with all the dependencies it needs. So, if you're using this dev container setup the way that I have, then, you shouldn't run into any issues. Okay, so it's done now, and we can see in the directory, it's generated 1, 2, 3, 4, 5, 6, 7 exploits. And, if we check out the exploits, we can see, yep, they look pretty similar as before. We're just using the request to execute a command against, say, a specific URL. And, really helping us get rid of a lot of the legwork here and finding and writing proof of concept exploits. Obviously, for more complicated exploits, you're probably going to have to do some late work yourself, but this should get you a good base going fairly quickly. Hey, I appreciate you guys tuning in. Please like and subscribe. Working hard for you to give you great content every day. And I'll see you in the next one.